Today's lesson is 3.2, fractional and decimal bases with exponents. The goal today is to simplify an expression when the base is a fraction or a decimal with an exponent. So in 3.1, we covered integer bases, so numbers like 5 squared, or 7 to the third, or you would see something like negative 11. That's not negative 11, that's negative 111 to the fourth. So these are all integers. Today we're going to cover when the base number is a fraction or a decimal. What do we do? And you'll see that nothing really changes. Let's go ahead and identify the key term. Really, it's just exponent, and this is another way of kind of defining what an exponent is. So an exponent tells you how many times its base is used as a factor. If you don't know what a factor is a number that is multiplied. So if we've got the example, 17 to the third, the base here is 17, and the exponent is telling us that the factor, or the base, is going to be a factor 3 times. So it's essentially just telling us it's going to be multiplied by itself 3 times. So 17 times 17 times 17. So you're going to see this word used throughout the homework today. How many times is the base being used as a factor? Well, if the exponent's 3, then the base is being used as a factor 3 times. Example number 1. So you can see here we've got we've got a fraction as our base. We've got 5 over 6 squared. So essentially with fractions, the process for taking it to the power is the same. You're just going to take each number individually to the power. So 5, 6 squared is the same thing as saying that the base 5, 6 is being multiplied by itself 2 times. So here's the base, and we're multiplying it by itself 2 times. With fractions, you just multiply straight across. So one way of thinking about this is, actually writing it out and multiplying the fractions straight across and seeing, what you get in the numerator, what you get in the denominator. And another way of thinking about this is just taking the numbers individually to the power that it's asking you to take it to. So I'm going to go ahead and make that mental note. And I'm going to abbreviate numerator and denominator individually. So if you look at this, 5 squared, well, 5 squared is 25, and 6 squared is 36. So I'm just taking the power to the numbers individually, and then whatever I get is my final answer. If we multiplied straight across, we would get the same thing. 5 times 5 is 25, 6 times 6 is 36. So 2 different ways of thinking about it. The base here was 5/6, and the factor, or how many times the base was a factor, was twice, because the exponent was 2. Example number 2. So here we now have a decimal that is being taken to the third power. So what is the process for taking decimals to the powers? Well, let's identify the base here. The base here is 0.02. I can go ahead and say 0.02. It's always standard practice to put a 0 on the left side of the decimal. And the number of times the base will be a factor is 3 in this example. So we've got 0.02 to the third power, which is equal to 0.02 times 0.02 times 0.02. And so there's a couple ways that you can solve these types of problems. One way is to just multiply 2 to the third power and then add the decimal spots afterwards, and that's the way I'm going to show you. So the first way we'll talk about is to take the number as an integer to the power and add the decimal places after. So if I'm going to do it that way, then what I'm saying is, 2 times 2 times 2, or I'm saying 2 cubed, is what? Well, 2 times 2 is 4. 4 times 2 is 8. So 2 cubed is 8. However, we're not cubing 2, we're cubing 0.02. So now we've got to add up the decimal places. So if I add up the decimal places behind the decimal, we've got 1, 2, 3, 4, 5, 6. Another way of easily doing this is saying, okay, in the original example, we had 2 places behind the decimal, and it was being taken to the third power. So 2 places behind multiplied by 3 is 6, right? And that's what we got when we counted. 1, 2, 3, 4, 5, 6. So 6 places behind the decimal. Here's 1, 2, 3, 4, 5, 6. So that's one way of figuring out how many zeros go in front of the number you get when you take the number as an integer to the power it's asking you to. And then we put the 0 at front, just as standard practice. So that'll be our answer here, right? Another way of doing this is to use a calculator. So if you wanted to use a calculator in this example, you'd plug in 0.02 to the third power, and you'd see what you got back. Let's go ahead and try that example now. So if you didn't want to just, take the number to the power and then add up the decimal places behind the decimal, then you can just use the calculator, but it's nice to be able to do it both ways. So we've got, we've got parentheses 0.02, parentheses to the third power, equals, and we've got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then we got the 0 out in front. So make sure as you input these in to Schoology for your homework that you are being very accurate with the numbers behind the decimal. Example number 3. So here we have a fraction again, and we're just going to do what we did in the previous example, except this time we've got a negative. We'll just take the negative with one of the numbers as we cube them. So we can say that negative 3 over 6, or 3 over 7, so negative 3 over 7 cubed. And the negative's inside the parentheses, so it's included in the base. We know that the base is negative 3 over 7. How many times is it going to be multiplied by itself? 3 times. So negative 3 over 7 times negative 3 over 7 times negative 3 over 7 is the same thing as just saying, what is negative 3 cubed? Well, negative 3 cubed would be negative 3 times negative 3, which would be 9, or positive 9. Positive 9 times a negative 3 would be a negative 27. So we get a negative 27 for our numerator, and then 7 times 7 would be 49, times 7 would be, I'm going to use a calculator for this one because that one seems like a fairly large number, times 7. 343. I'm going to leave the negative out in front, and then when I put this into Schoology, I'm just going to use a backslash for the division. Whoops. Just like that. Example number 4. So here we have a decimal that's being taken to the fourth power. And you remember from the previous lesson, the negative right here is included in the base when it is in parentheses, and right now it is not in parentheses, so we're just going to take that negative, and whatever we get in the end, it's going to be some negative number, probably. So our base here is 0.05, and the number of times it will be a factor is 4 times. So we can just say that 0.5 to the fourth equals 0.05 times itself 4 times. Now, if we're going to try to multiply this out on our own, then we're going to take 5 to the fourth power, and then we'll add in the decimal places at the end. So 5 to the fourth power, well, 5 squared would be 25, right? 5 cubed would be 25 times 5, which would be 125. So then 5 to the fourth power should be 625, and let me verify using a calculator. 5 to the 4th power equals 625. 625. Okay, so 625 would be 5 to the 4th, but we're taking 0.05 to the 4th. So we're going to go ahead and put these numbers in. 625. That's 3 spots. How many spots behind the decimal do we need to make sure we have? Well, 1, 2, 3, 4, 5, 6, 7, 8. And you should remember this process from when you multiplied decimals in middle school. So we've got 8 spots behind the decimal. This is 1, 2, 3, 4, 5, 6, 7, 8. With the 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. Let's see if that's what we get when we put it into the calculator. So we've got negative on the outside, 0.05, parentheses, to the 4th power equals 1, 2, 3, 4, 5, 6, 7, 8. And I make sure I verify that before I put it into Schoology so that it's accurate. Okay? And that is the last example for today. So good luck on the homework.